The typical candidate for a knee replacement has osteoarthritis, where the cartilage in the knee has worn away. Knee replacement surgery restores the worn areas with an implant. To help place the implant properly, the surgeon can use an instrument custom designed for the patient's damaged anatomy. A successful knee replacement depends on its alignment with the femur and tibia, the upper and lower leg bones that connect at the knee. That's a challenge because knee implants are standard, while every patient's bones are unique. So starting with an MRI scan of the patient's knee, this medical device company produces custom-made surgical templates. Plastic devices the surgeon uses to sculpt the surface of the patient's bones to align the knee implant accurately. The surgeon no longer has to visually calculate the bone cuts on the spot in the operating room, which takes more time and is more invasive. An engineer uses the MRI scan to create 3D models of the patient's femur and tibia. The patient's cartilage has worn out in between these bones, causing painful rubbing that erodes the bone surface. The implant effectively replaces the damaged bone and cartilage. Once each bone model is ready, another engineer applies a 3D model of the correct size implant. Then, following directions the surgeon has provided, performs virtual surgery on the bone model. This will properly align the implant to the patient's specific anatomy and fit it to the angle at which that particular knee moves. During this surgery simulation, the computer records every bone cut. The surgeon reviews and approves this surgical plan only once before manufacturing begins. The computer, which recorded the bone cuts, guides a 3D printer to produce plastic templates for both the femur and tibia. The surgeon will use these to repeat the exact same cuts in real life. The 3D printer applies a layer of powdered plastic. Then, following the computer model, solidifies select areas with a laser. This process keeps repeating, building up the shape of these surgical templates layer by layer. One printer run produces personalized templates for up to 50 patients at a time. So the laser inscribes the patient's name and identification code on each part. Once the printing's done, it's just a matter of breaking up the unsolidified powdered plastic. And fishing out the templates. They brush off the bulk of the remaining powder. The posts on the bottom are the points at which pins affix the template to the bone during surgery. Next, the templates go into a tumbler containing plastic balls and air jets. As the drum rotates for 20 minutes, the balls knock off, and the air jets blow off most of the remaining powder. The templates exit the tumbler 90% clean. They go through 2 wash cycles to remove the last remnants of powder. Before packaging, they'll be sterilized. But first, every template must pass a quality control inspection. Using a laser, a technician scans it to make sure the manufacturing process produced an exact match to the patient's bone. This model shows how the femur and tibia form the knee joint, and how the surgeon secures the customized template onto each of these bones. Thanks to these devices, the surgeon doesn't have to figure out the bone cuts on the fly in the operating room. They're all pre-calculated by the computer model. This method eliminates several steps required in standard surgery. The operation takes less time and requires half as many instruments to set up and clean up. And because the surgeon no longer has to drill a hole in the bone to check the knee implant's alignment, the patient experiences less pain and bleeding, and a smaller chance of developing complications.
root.